Okay, so changing dimensions of 3D figures. So basically we're gonna look at what happens to different types of characteristics of our 3D figures if we happen to change dimensions, okay? So first one, we're gonna look at this, and this has to do with perimeter and area. So it says triangle ABC is congruent to triangle XYZ. What is the scale factor of the similar polygons? How are the perimeter and the area of the similar polygons related to the scale factor? Can we write the ratios of the corresponding side lengths? So basically, in order to find the scale factor, that's the first thing we're going to work with. Is basically, we know that these two are similar. They may not be congruent, but they're similar. And so given that information, what we're able to do is we're able to compare the different side lengths. Okay? And so my angle, or my side opposite my right angle, is 15 in the big one and 5 in the small one. Right? So this side is 5 in the small one, 15 in the big one. If we divide those two by each other, we get equal to 3. Okay? Now we can go ahead and compare the other ones. 4 and 12, they're both on that bottom. So the big one on the top, the small one on the bottom. That's also equal to 3. Compare the last side, 3, 9 and 3. 3. And so because all of my ratios here tell me that it's 3, what that tells me is the ratio is equal to 3, so the scale factor is 3. So basically what we're able to do is what you can notice is that from the small triangle, the ABC triangle, to the XYZ triangle, what has happened is that each of our side lengths has been multiplied by 3. So it has been multiplied by a scale factor of 3. And so we've identified our scale factor as 3. Okay, so I'm going to write that here. My scale factor is 3. And remember, the way that I identify my scale factor here is I take my bigger portion over my smaller portion, divide them by each other, and see what's the relationship between both of those different parts, those different sides. So my scale factor is 3. Now what I'm going to identify is how does this scale factor affect my perimeter and my area? Okay, so how do I identify perimeter? Well, the perimeter is equal to all of my sides added together, right? So 5 plus 4 plus 3. The perimeter of this smaller triangle is 12 units. This one, 15 plus 9 plus 12. The perimeter of this one is going to be 36. Well, now I'm going to go ahead and look at the ratio between 36 and 12. Again, my bigger one's going to be on the top. I can write that here. My big one always goes on the top, and then my small one always goes on the bottom. So 36 divided by 12. What is that? That is 3. Well, what I can determine from that is whenever I change the dimensions of my side, my perimeter is going to be equal to my scale factor. That's what this is telling me right here. My perimeter is equal to my scale factor. My scale factor was 3, and my perimeter changes by a scale factor of 3 as well. So my perimeter is equal to 3. Remember, what you do first is you identify the perimeters of both of those, the smaller triangle and the bigger triangle. Take the bigger over the smaller, divide, and see that your perimeter ratio is going to be equal to your scale factor. Now, what about area? We find the area of a triangle by doing 1/2 over base times height. Our base is going to be 4. Our height is going to be 3. That is going to be equal to 6. Over here, same thing, 1/2. Our base is 12. Our height is 9. That is equal to 54. Now again, I take my bigger over my smaller, divide those by each other. And what I notice is that I get 9. So my volume is 9. So basically that means when I increase each of my side lengths by a factor of 3, my volume increases by a factor of 9. Or not my volume, my area. Sorry, I'm looking for my area. That was the area equation. So yes, area. My area increases by a factor of 9. So what this tells me is that my area scale factor is going to be equal to the square of the scale factor. What this is saying is our scale factor is 3. We square it, and that is equal to 9, right? That checks out. So our area, whenever we change the dimensions of our sides by a specific scale factor, is going to be affected by the square of that scale factor. And so in this instance, it's going to be 9. Okay, questions about this? Questions, concerns? So basically what we're identifying here is how is my perimeter going to change and how is my area going to change if for some reason I happen to change each of my sides by a scale factor of 3. So basically what that looks like is multiplying this by 3, multiplying this by 3, multiplying this by 3. That's increasing all of my sides by a scale factor of 3. So what I'm identifying is what does that mean for my perimeter? How is my perimeter going to change? Well, my perimeter is only going to change by the scale factor, so multiply by 3 as well. How is it going to affect my area? Well, my area is going to get squared. And so it's equal to the square of the scale factor. And so that's what we're identifying here. Okay. So let's move on to the next one. Okay. So how do we know that solids are similar? So two solids are similar if they are the same shape. So these two are the same shape, right? They're both rectangular prisms. And they have proportional corresponding measurements. So basically, the sides are being increased by a scale factor. And so we can identify the scale factor of this. Again, you want to do big over small. And just pick a side you want to work with. I'm going to first start with these sides, 6 and 3. It's 6 in the big one, 3 in the small one. Divide those by each other. That is 2. I'll do these two, 4 and 2. Divide that. That's also 2. This one and this one. 2 and 1. And that's also 2. So what this is telling me is that my scale factor is 2. What that means is basically all I did was I multiplied each of these sides by 2 to get my larger rectangular prism. And so because I'm able to do that, because they're both the same shape, they're both going to be rectangular prisms, and because they have proportional corresponding measurements, they're all increased by a scale factor of 2. All the sides are increased by a scale factor of 2. That means these two are going to be similar solids. Okay. What about these two? Are these two similar solids? Well, we can automatically say they're not going to be similar solids. And the reason is because one is a right cone and the other one is an oblique cone. We want similar solids to be the same shape. And so one is a right cone and one is an oblique cone. And so because they are not the same, those two solids will not be similar solids. Okay. So now let's look at similar cones. So we're told these two are similar. These two cylinders are similar solids. So basically they're the same shape and they're going to be proportional to each other. That's what we're given. Compare the area of the circular base of the larger cylinder to the area of the base of the smaller cylinder. So we know we're working with area here. Okay. Because we know we're working with area, what we want to do is we want to identify the area of the smaller base, or the area of the smaller cone, and the area of the larger cone. So area of a cylinder is going to be equal to, or areas of the base. So the base is going to be equal to pi r squared. That'll give me my areas of my base. So basically the area of this base and the area of this base, because they're comparing those areas. This one is equal to pi n squared, which is equal to 81 pi. This one's equal to pi 3 squared, which is equal to 9 pi. Okay? And so now what it's asking me to do is compare the areas of those bases. Again, I want big over small. So 81 over 9. That allows me to cancel these two out. And now I just have 81 divided by 9, which is 9. Okay, so therefore, my area is going to be increased by a scale factor of 9. Okay, so that's basically all this one's asking. Now we're going to look at surface area. The surface area of a similar solid theorem basically says if proportional dimensional changes are made to a solid figure, then the surface area will change by the square of the scale factor. So basically what this is telling us is according to the surface area theorem, what we can determine is that my scale factor, I can identify my scale factor, and that my square area is going to be changed by the square of that scale factor. So the way that I identify my scale factor is you're basically comparing parts, right? We looked at scale factor earlier, and basically you're just comparing parts. So here our parts are our height and our radius. So our height in our big one is 12. Our height in a small one is 4. That's equal to 3. So that's, I'm identifying my scale factors. You compare the parts. 9, 3, that's also equal to 3. So my scale factor is 3. But what this theorem is telling me is from that, I can identify how my surface area changes from one to the other, because my surface area is going to be equal to the square of that scale factor. Well, if you square that scale factor, what it tells you is my surface area should be changed by 9, a factor of 9. Okay, so my surface area should be changed by a factor of 9. And I can go ahead and check this. Here I'm given my surface area of my larger and my surface area of my smaller. And I can go ahead and compare this. So my bigger one and my smaller one. And I want to see if I also get 9. So these cancel out. And when I divide those two, I do in fact get 9. And so it is true that my surface area is going to be equal to the square of my scale factor. Again, I can find scale factor by comparing my parts. And then I can combine my surface area scale factor by either taking both of those surface areas, comparing them to each other and finding the ratios between them. Or what I could simply do is just square my scale factor according to this theorem. Questions? Okay. Here is another example. Here we're also working with surface area. It says determine surface area given similar solid. So here we have similar solid. And in this question, we're told the square pyramids are similar, so they are similar shapes. If the large pyramid has a surface area of 149.76 centimeters squared, what is the surface area of the smaller pyramid? Okay, well, what we know is that we can go ahead and determine our scale factor. So our scale factor compares the parts. It compares big to small. That's the first thing we want to do. We want to find our scale factor, because if we find our scale factor, we can square it and find out what our surface area scale factor is. So my big one, 7.2 divided by 5.4. That is equal to 4 over 3. So my scale factor is 4 over 3. What my theorem previously told me is that the surface area will change by the square of the scale factor. So basically, my scale factor squared. That gives me 16 and 9. So this is how my surface area will change from my bigger unit to my smaller unit. Okay, so now I know my surface area scale factor. Okay, it's that one right there, according to that theorem. Given this information, what I'm able to do is I'm able to find what my surface area is going to be equal to, because my surface area will basically be changed by this scale factor. So 16 over 9, that is my scale factor. That is how my surface area of my larger pyramid compares to my smaller pyramid, will be equal to, again, this is my bigger part. This is my smaller part. My bigger surface area was given to me. And that will allow me to find now my surface area of my smaller one. Okay? So first thing I wanted to do, the first thing I did was I identified what is my scale factor? What is my surface area going to change by? And now, using that information, now that I know what my surface area will change by, now I can go ahead and identify my smaller surface area. So now I have this equation right here. You just do cross multiplication. So this times this, 9 times, will be equal to, according to cross multiplication, will be equal to 16 times x. And then I'm just solving. So I'm multiplying those two together. In order to find x, I want to divide by both sides by 16. That'll allow me to isolate x. And now x is equal to 84.24. That x would represent the surface area of my smaller pyramid. So this surface area will be equal to, okay? And what this is telling me, according to what I've identified, is that my surface area has been multiplied by 16 over 9 to give me my resulting surface area of my larger pyramid. What I've also been able to identify is that my side right here, that was 5.4, was multiplied by 4 over 3 to give me my other side over here, 7.2. Okay, so that is what these different scale factors are telling me. The scale factor of the surface area is telling me what was my surface area multiplied to give me my resulting surface area. And the answer is 16 over 9. And the scale factor tells me what was my different dimensions, my different sides multiplied by to give me my resulting sides. Okay, questions here? So what about volume? How does volume change if we were to increase a dimension by a certain scale factor? Okay, so this tells us these two spheres are similar, right? Because they're both spheres. It says the spheres' volumes are similar. Find the scale factor of the ratio of their volumes. Well, what we know about scale factor is that the scale factor determines how my dimensions have been changed. So again, big over small. And here we're working with radiuses. How are my radiuses changed? Well, in my bigger sphere, my radius is A. And in my smaller sphere, my radius is B. Right? So that basically tells me that B was multiplied by a scale factor of A over B to give me A. Right? So that is my scale factor. That just tells me how my dimensions change. How do my radiuses change in this instance? That's the only dimensions I can change. So my scale factor is A over B. Okay? So now it says find the scale factor and the ratio of their volumes. Well, I can do this two ways. I can take both of these volumes and divide them by each other. So bigger, small one. The bigger is this one. The smaller volume is going to be this one. And I can compare those. So these would cancel out. Oh, hold on, this is B. This would cancel out, and I'll leave me with A cubed over B cubed. You can't simplify that any further. Oh, no. And so they give me A cubed over B cubed would be my scale factor of my volume. So I could do it two ways. I could either identify my scale factor, and what I'll realize is that I can identify my scale factor and cube it to find how my volume changes. Or what I can do is compare those two volumes if I'm given those two volumes, which it gives you the same thing, A cubed over B cubed. What this tells me is that my volume is equal to the cubed of my scale factor. So I can find my scale factor and cube it to find how my volume changes if I were to happen to change the dimension of my original sphere to my smaller sphere to my bigger sphere. Okay, so we'll look at an example of this. Here's an example. So the volume of a similar solid theorem says if proportional dimension changes are made to a solid figure, then the volume will change by the cube of the scale factor. Okay, so here we have it. Okay, so my perimeter, here we're given my perimeter, that's what we're given to start with, okay? Remember that we identified that my perimeter is equal to the scale factor. So if I find how my perimeters are related to each other, I'll be able to find my scale factor. So big over small, that is equal to 2. So my scale factor is 2. So basically from here to here, what I have done is I've increased all of the sides by a scale factor of 2. I've multiplied these sides by 2. That's basically what my scale factor tells me. And the reason I was able to use my perimeter to compare or to find the scale factor is because my perimeter is going to be equal to my scale factor. So that's why I was able to do it. Okay, but now I know my scale factor. Well, let us remember that we know that the volume will be changed by the cube of the scale factor. So 2 cubed equals 8. This tells me that my volume will be multiplied by 8 from the smaller pyramid to the larger pyramid. So my volume increases by a factor of 8. It's multiplied by 8. Okay? Given this information, am I able to find, in this instance, is the volume of my larger pyramid in this instance? Okay? Well, I'm told that my smaller pyramid has a volume of 36.9 feet. Okay. Give me 1 second. Okay. So basically what that's telling me is that my volume is going to change by a scale factor of 8. Well, the way that I can identify my missing volume, my volume of my larger pyramid, is to take my scale factor is equal to, I'm looking for the volume X over the volume of my smaller one. Now I just cross multiply. Divide by 9. X is equal to 73.8. X being equal to 73.8 tells me that my volume of my larger pyramid is equal to 73.8. So by identifying my scale factor, what I'm able to do is I'm able to identify how my volume changes as a result of me increasing each of my sides by a scale factor of 2, which I just saw. Go here. Okay. So now let's relate surface area and volume. It says the surface area of 2 similar solids, so I do in fact have 2 similar solids, and I have those, so I can go ahead and write those down. The surface area of the smaller solid is going to be 121 millimeters squared, and the volume of my bigger solid is going to be 196 millimeters squared. If the volume of the smaller solid, so I'm given the volume of the smaller one, is 51.27 millimeters cubed, what is the volume of the larger solid? Okay. Well, the first thing I want to go ahead and do is I want to go ahead and identify what my scale factor is. What is being changed in my surface area to give me that surface area, okay? So I can identify what my surface area scale factor is by taking my larger and my smaller and dividing them by each other. And that is equal to 14. It's easier to do it this way. So if you think about it, my surface area is the square of my scale factor. So basically my surface area is x squared. And x would represent my scale factor. So in order to find my scale factor, if you think about it, that the surface area is equal to x squared, in order to find x, what I want to do is I want to go ahead and take the square root of both sides. So I want to square it, and that will give me what x is, because that allows me to eliminate the square root. If I square it, it allows me to eliminate that square root, and that tells me that my square factor or my scale factor was originally 14 over 11. That's the easiest way to do it. You're just working backwards. So if it's equal to the square of the scale factor, then you're going to work backwards to identify what was the scale factor that you squared to get your surface area. And so now I know my scale factor is 14 over 11. Okay. And given this information, now what I want to do is I want to identify the relationship between my volumes. Well, I know my volume is equal to the cube of my scale factor. And so my volume would be equal to 14 cubed over 11 cubed. All right, so that would give me how my volume changes in relation to my scale factor. Now, this is what I can take to identify what the volume of my larger solid is. 14 cubed, 11 cubed. I know that my smaller one, so the bottom one, has a volume of 51.27. So I'm looking for x. What is the volume of my large one? Remember that we put these in relationships big over small. And now I can go ahead and cross multiply. This is equal to, this is a large number. This is x, so I'm going to divide by 1,331 on both sides. And that tells me x is equal to 105.70. So that would be the volume of my larger figure. So basically the first thing I want to do is I want to write down the information I'm given. I'm given information about surface area and one of the volumes. And so given that I'm given both of this information about surface area, I can find my surface area expression, which represents the ratio between my smaller to my larger, which was this expression right here. And using that, I can identify my scale factor. So my scale factor, what originally gave me my surface area of this ratio, was my scale factor squared. And so I can eliminate that square by doing the square root on both sides. And now I have my scale factor. Now that I have my scale factor, I can find my volume ratio by multiplying that by, or cubing it. And so this is the ratio of how my volumes are related to each other. And given that, and given the fact that I have one volume, the volume of my smaller solid, I can go ahead and find the volume of my larger solid, which is my end goal here. Any questions? Okay. So basically what we're able to do today is what we're able to determine is if a proportional dimension changes, if any proportional dimensional changes are made to a solid figure, then the surface area will change by the square of the scale factor and the volume will change by the cube of the scale factor. The perimeter will stay the same. It'll be equal to the scale factor. And our area will be equal to the square of the scale factor. So given these relationships, what I'm able to determine is if I take a figure, say I have a square. If I take a figure and for some reason what I want to do is change the dimensions by a specific scale factor. So I want to increase not only the length, but the width of this square by the same scale factor. Say I want to multiply it by 2. Then what that tells me is if I change my dimensions by 2, something will happen to my perimeter, something will happen to my area, something will happen to my surface area, and something will happen to my volume. More specifically, say that I knew that the perimeter of this was equal to 4. Or I can just tell you what the perimeter actually is. Okay, say that this was originally 1 each. Yeah, so my perimeter is equal to 4. Okay, now say that what I've done is I've taken each of my sides of the square and I've increased them by 2, by a scale factor of 2. Now this side is equal to 2, this side is equal to 2, this side is equal to 2, and this side is equal to 2 because I've increased each of my dimensions. My perimeter will increase by the same scale factor, so it'll also be multiplied by 2. So 8, right, which is true. If I add 2 plus 2 plus 2 plus 2, my perimeter has been increased by 8. So my perimeter is equal to my scale factor. So if my dimensions change by multiplied by 2, then my perimeter will also be multiplied by 2. However, once we get to area, surface area, and volume, my area is equal to the square of the scale factor. So here my area would be equal to my length times my width, which is 1. If I were to increase each of my sides by a scale factor by 2, my area would change. And my area would change by the square of the scale factor. So my scale factor was 2. The square of my scale factor is 4. And so it should change by 4. So now my length times the width is 2 times 2, which is 4. Well, 1 compared to 4 is a multiplication of 4. And so you can see that my area has changed by a factor of 4, or the square of my scale factor, which was 2. Okay. My surface area would also be changed or be equal to the scale factor of 2. So my scale factor, or my surface area of this square to this square would be a scale factor of 2, so it would change by 4. And then my volume would equal to the cube of my scale factor, so my volume would change by a factor of the scale factor cubed. So 2 times 2 times 2, I think it's 8. Okay. And so basically what all this is saying is if for some reason I were to change my dimensions, change my sides up, how would that affect my perimeter? How would it affect my area? How would it affect my surface area? And how would it affect my volume? And this is it's telling you exactly how it would be affected. Okay, but we'll work through some more examples tomorrow. But if there's no other questions, you guys may log off, and I will see you guys tomorrow. Bye, guys.